Welcome students. Welcome to the ChemQuest and to the class of Analytical Chemistry. In this lecture today we will discuss about chromatographic separations. We will see basically the history of chromatography and the two phases of chromatographic separations. So let's continue. So in 1901, the Russian botanist Michael Sweet invented adsorption chromatography during his research on plant pigments. Actually, Michael Sweet, he was the scientist who invented chromatography, and the phenomena he studied basically was adsorption. Adsorption we will discuss in detail in the next lectures, but it is different from the absorption in the sense that in absorption there is complete mixing between two liquids, but in adsorption there is the adsorption of particles of one phase on the surface of another phase. So this is adsorption. तो एडजॉर्प्शन के अंदर क्या होता है कि एक सल्यूट के पार्टिकल्स जिसे हम सल्यूट बोलेंगे जो थोड़ी मिकदार में होगा वो सॉल्वेंट के ऊपर एडजॉर्ब कर जाएंगे. अब सॉल्वेंट जो है वो लिक्विड सॉल्वेंट भी हो सकता है और सॉलिड सॉल्वेंट भी हो सकता है. तो व्हाट ही हैज़ डन, ही सेपरेटेड डिफरेंट कलर्ड chlorophyll and carotenoid pigments of leaves by passing an extract of the leaves through a column of calcium carbonate, alumina and sucrose, eluating them with petroleum ether or ethanol mixture. So what he has done basically we will see in detail on the next slide, but he has filled a column को उसने fill किया with calcium carbonate, एलुमिना एंड सुक्रोज के साथ और फिर उसको इल्यूवेट किया with petroleum ether and ethanol mixtures. Then he coined the term chromatography in 1906 publication. So उसने chromatography का term 1906 में अपनी एक publication में coin किया, and he has taken actually two Greek words, chroma which mean color and graphos meaning to write. So chromatography literally meaning color writing. Because he has obtained different colored pigments separated by the eluating mixture. That is why he has used this term, that is chroma meaning color and graphos meaning to write. Sweet's original experiments went virtually unnoticed in literature for decades. तो कई दहाइयों तक जो उसके ओरिजिनल एक्सपेरिमेंट थे किसी ने उसको नोटिस नहीं किया, बट एवेंचुअली अदर्स अडॉप्टेड इट. लेकिन बाद में फिर एवेंचुअली ये एक बहुत बड़ी फील्ड बन गई और दूसरे लोगों ने इसको अडॉप्ट किया. टुडे देयर आर सेवरल डिफरेंट टाइप्स ऑफ क्रोमेटोग्राफी. सो वी विल एक्चुअली स्टडी इन द लेक्चर्स ऑफ दिस सीरीज दैट हाउ मेनी टाइप्स ऑफ क्रोमेटोग्राफी आर देयर और ये कितनी बड़ी एक फील्ड बन चुकी है और किस तरह से लोगों ने इसको अडॉप्ट कर लिया है. So this is the original chromatography experiment picture. So what Sweet done, he has taken a glass column. So you can see this is the glass column and this is filled with limestone, that is calcium carbonate. So inside the gray color is the calcium carbonate, and as we have done in the glass experiment in the laboratory, that leaf extract, right, जो हमने लीफ को पेस्टल मोटर में इथाइल अल्कोहल के साथ उसका पेस्ट बना के जो हमने वो पिगमेंट्स एक्सट्रैक्ट किए थे, दिस एक्सट्रैक्ट दिस ही हैज़ अप्लाइड एट द टॉप ऑफ दिस कॉलम. और इल्यूवेंट उसने जो यूज़ किया, दिस वाज इथाइल अल्कोहल. फर्स्ट दिस कॉलम, दिस इज फिल्ड विद कैल्शियम कार्बोनेट, potted limestone, and then extract of plant pigment is applied on the top, and then we will use ethyl alcohol as eluent. तो फिर हम eluent जो ethyl alcohol है वो ऊपर टॉप से हम अंडेलेंगे, ठीक है, टॉप से हम डाल देंगे. और उसके बाद क्या होगा कि we will get a series of different colors separated by the eluent, that is ethyl alcohol. So a series of colored bands is seen to form. You can see right different colors here corresponding to different pigments in the original plant extract. So these colors actually they are different plant pigments and these are separated by this simple experiment. Okay. These bands were later determined to be chlorophylls, anthophylls and carotenoids. और इन बैंड्स को फिर बाद में फर्दर क्लासीफाई किया गया एज क्लोरोफिल्स, xanthophylls and carotenoids. So by means of this simple experiment, he has separated different colors which were present in combined form in plant extract. So this is Michael Smith, Russian botanist, and he worked from 1872 to 1919. And in 1901, with his research on plant pigments, he invented chromatography. And the pigments on which he has worked on and the pigments he got separated, they were chlorophylls, xanthophylls, and carotenoids. So now we will see the definition of chromatography according to International Union of Pure and Applied Chemistry. So IUPAC drafted a recommended definition of chromatography. Chromatography is a physical method of separation in which the components to be separated are distributed between two phases, one of which is the stationary phase, while the other, the mobile phase, which moves in a definite direction. So, according to International Union of Pure and Applied Chromatography, chromatography एक फिजिकल मेथड है सेपरेशन का, जो कंपोनेंट्स हैं उनको ये सेपरेट कर देता है बिटवीन टू फेजेस, जिनमें से एक फेज जो है वो स्टेशनरी फेज होती है और दूसरी जो है वो मोबाइल फेज होती है, जो कि एक डेफिनेट डायरेक्शन में मूव करती है. Okay, so now we will see in detail the phases in chromatography as we discussed on the previous slide. The mobile phase, the solvent moving through the column. So mobile phase is the solvent which moves through the column. So we have this, for example, column, and this column is packed with this stationary phase, and then from above we will add fresh solvent, and we call this moving solvent as mobile phase, or a more technical name for it is eluent. We will call it as eluent. uh, the stationary phase, the one that stays in place inside the column, is most commonly a viscous liquid chemically bounded to the inside of a capillary tube or onto the surface of solid particles packed in the column. So जो stationary phase है जो कि stay करती है inside the column, so this is the glass column और इसके अंदर stationary phase जो है वो stay करती है. ये एक viscous liquid हो सकता है which is chemically bonded to the inside of a capillary tube. So इस column को अगर हम एक capillary tube मान लें तो, और इस कैपिलरी ट्यूब के अंदर फॉर एग्जांपल हम एक सॉलिड स्पोर्ट लेंगे और एक विस्कस लिक्विड केमिकली बाउंड हो जाएगा उस स्टेशनरी फेज के साथ. इस तरह से एक हमारे पास सॉलिड स्पोर्ट होगी और उस सॉलिड स्पोर्ट के अंदर एक विस्कस लिक्विड स्टेशनरी फेज के तौर पर एक्ट कर सकता है. Alternatively, the solid particles themselves may be the stationary phase. So viscous liquid may be the stationary phase, but as this is liquid, so it should be sported on a solid sport. Or otherwise, the solid particles, as we have seen in the Michael Smith's experiment, as he has used calcium carbonate as the stationary phase. So the solid particles or the stationary phase, it may be solid itself, or it may be viscous liquid sported on solid sport. In any case, the partitioning of solute between mobile and stationary phase gives rise to separation. So आप जो stationary phase है वो solid हो या liquid हो, और जो eluent है या जो mobile phase है वो तो liquid ही होगी. तो दोनों cases में जो partitioning of solute है, जो solute के particles हैं, they will separate themselves between the mobile and the stationary phase. और इस तरह से different जो components होंगे solute के, उनको हम separate कर पाएंगे by partitioning them between mobile phase and stationary phase. So if we discuss this diagram, for example, this is the column, this is packed inside with stationary phase, and from the top we will add eluent. and this is the porous disc, and this is the knob from which the eluent will come out at the end, right? Now we have, for example, these two components A and B. These are the solute components which we have added, and after that we will add actually eluent. In this diagram, it is here mentioned that solute A is having, which is of, for example, here it is given, it has been given blue color. So solute A, it has greater affinity for the column और for the stationary phase. तो ये stationary phase के साथ इसकी binding ज़्यादा है solute A की. तो जिसकी stationary phase के साथ binding ज़्यादा होगी वो ज़्यादा देर तक कॉलम के अंदर रहेगा, और जो solute B है, as you can see that it is emerging first. जैसा कि आप देख सकते हैं कि solute B पहले बाहर आ रहा है, तो इसका मतलब ये हुआ कि इसकी affinity stationary phase के साथ कम है. That is why it is emerging out first. तो इस तरह से पहले हम solute B को कलेक्ट कर लेंगे राइट फ्रॉम द बॉटम, और उसके बाद solute A जो है वो इमर्ज होगा, और इस तरह से हम बाय मीन ऑफ क्रोमेटोग्राफी ये दोनों solutes जो हैं A और B, इनको सेपरेट हम कर सकते हैं. So these are different terms which we normally use for chromatography. Fluid entering the column is called eluent. So this is eluent. The fluid or the solvent, or you may say mobile phase, right? Which we use to flush through the column. This is called eluent. Actually, this is the mobile phase. And fluid emerging from the end of column is called eluvate. तो वो मोबाइल फेज जो हम यहाँ पर डाल रहे हैं, ऊपर वाली साइड पे उसको कहेंगे इल्यूवेंट, और नीचे से सॉल्वेंट जो फ्लश होगा आफ्टर जो बाहर निकलेगा आफ्टर फ्लशिंग थ्रू द कॉलम, इसको हम बोलेंगे इल्यूवेट, राइट? सो एट द टॉप वी विल कॉल दिस मोबाइल फेज एज इल्यूवेंट, एंड बाय द एंड ऑफ एक्सपेरिमेंट वी विल गेट इल्यूवेट. The process of passing liquid or gas through a chromatography column is called elution. So the process by which liquid or gas actually जो मोबाइल फेज है वो हमेशा या तो लिक्विड होगी या गैस होगी, because it is a moving phase, so it should move. As solids we know that they cannot move, they are stationary, so solid can be used as the stationary phase, and liquid and gases they both can be used as mobile phase. So the process in which the liquid or gas they will pass through the chromatography column, this is called elution. Columns are either packed or open tubular. So these columns they can be packed or open tubular. Here the further explanation of packed and open tubular column is given. A packed column is filled with particles of stationary phase, as in figure 1. So in figure 1 this is the packed column, right? Because you can see that it is filled with the particles of the stationary phase. जबकि जो open tubular column है, this is a narrow hollow capillary with stationary phase coated on the inside walls. जबकि जो open tubular column होगा, this will be a narrow and hollow capillary, यानी अंदर से hollow capillary होगी, capillary tube होगी, और उसकी inside walls जो हैं उसके ऊपर कोट कर दी जाएगी स्टेशनरी फेज को, तो वो ओपन ट्यूबुलर कॉलम होगा. जबकि ये जो आपको कॉलम नजर आ रहा है, दिस इज द पैक्ड कॉलम, in which you can see that stationary phase is filled or packed inside the column, while in case of open tubular column this will be a narrow capillary tube, and this it should be hollow as well, and only inside the walls the stationary phase will be coated. So that is the end of this short lecture. Hope that you have enjoyed this lecture. So if you have understood, do subscribe, like and share. As you know, sharing is caring. So we will meet inshallah with another lecture corresponding to this series. Till then, Allah Hafiz.